3, 2, 1.
Science news for students. Snot Science, a snotty setup. Here's how to test how far a sneeze will spew snot. Proper hygiene means covering your nose when you sneeze, but a lot of people don't. How far away do you have to be to stay safe from their germs? It's flu and cold season when everyone is trying hard not to get sick. A flu shot may help you to avoid the worst, but no matter how much you try to protect yourself, it seems someone nearby is sneezing away through most of the winter. Those sneezes spray out tiny drops of mucus in which cold and influenza viruses hide. Sometimes it's a fine spray, and other times the snot gets everywhere. It's pretty disgusting, but also it's a good idea and a good opportunity to ask some questions. How far does each kind of snot travel? And how far away do you have to stand to stay safe from a viral spread? Explainer, what is a virus? If you want to know more, click on that link. I try to answer these questions in our first DIY science video. And here I will show you how to do this experiment yourself, how to analyze the data, and how you can interpret the results. The idea for this experiment came originally from an experiment on Science Friday. The website showed how to plot out sneezes in a histogram, a graph showing how data points are distributed over a range. I decided to turn this into a different experiment, one that compares thick snot to thin. The two types of mucus differ from their viscosity, which is a measure of a fluid's resistance to flow. Thick, gloppy boogers have a high viscosity. They slowly ooze out of your nose. Thin, drippy snot has a low viscosity. It drips very quickly. We can use what we know about viscosity to form a hypothesis, a statement that can be tested. The statement will compare a control, something in the test that will not change, to a variable, some factor that is changing. Hypothesis. Thin snot will fly farther and spread more than thick snot. Now we have a hypothesis. How do we test it? In the Science Friday experiment, a small plastic dropper served as a fake nose to spray colored water onto paper. This serves as a sneeze model, which is a representation of something that happens in the real world. I decided to do something similar, using a dropper with colored snot. Because the best experiments are repeated many, many times, I didn't want to replace the paper over and over. Instead, I used plastic shower curtains, which I could wipe off in between sneezes. At the bottom of this post, I've written down my materials list, along with the cost that I paid for each item. Creating snot plots. For the experiment, I wanted plenty of open space. To film the video, my team used a large conference room. I lined up white shower curtains and taped them to the floor. At one end of the shower curtains, I set up a table with my artificial nose on it. Then, using a permanent marker and a measuring tape, I drew a 5 meter, which is 16.4 foot, line on the tarp stretching out from the table. I marked the line every half meter, 50 centimeters, or about 20 inches. Then I made my snot. For thin snot, I used a half a cup of water and a few drops of blue food dye, enough to turn it a nice dark blue. I didn't use red or yellow in this test. Yellow wouldn't show up well on the tarp, and red looked a little too much like someone was sneezing with a bloody nose. To simulate viscous mucus, I couldn't use water alone. I needed to find a combination of substances that would more closely stand in for snot. Mucus is mostly water, but added sugars and proteins give it its glop. So I needed fake snot with the same or similar ingredients. I realized I could use gelatin for my proteins and corn syrup as my sugar. With water, they make a good substitute for thick, gloopy snot. I followed the recipe I found here, but I discovered that making snot is harder than it might seem. I had to tweak the recipe. To get consistent results, I followed these directions carefully. I brought half a cup of water to a boil in a small pot. Then I immediately took the water off the heat. The original recipe says to keep the water boiling, but I found if I did that, my goo never thickened. Mix 3 tablespoons of gelatin into the hot water and add food coloring. I used green. The gelatin tends to clump, so stir it with a fork to break up the clumps. Add a 1/4 cup of corn syrup. When you dip your fork in again, it will bring up a long, gloppy strands of snot. Do not stir the corn syrup in vigorously, as this will also stop the mucus from forming. To stir, stick in your fork and make very slow, lazy circle or two. No more than that. The mixture will thicken more as it cools. To keep it at the same thickness, add 1 tablespoon of water to the mixture every 5 minutes. Remember to stir as little as possible. You can, if you want, eat this mixture. I wouldn't recommend it. It smells. In experiments, it's important to keep everything you do as consistent as possible. The most important variable for me was thick mucus versus thin mucus. What if temperature affected the thickness of my liquid? My mucus was hot, but the water I was using was not. It had just come from the tap. I made sure that both of my snot mixtures were the same temperature. Because the recipe for the thick snot requires bringing the water to a boil, I brought my thin snot to a boil too. Once I had my thick and thin mucus, I loaded each into a dropper, smacked the bulb, you can yell achoo for good measure if you'd like to, and measured how far the snot squirted. For each sneeze, I measured how far the fluid managed to fly. I also looked at where the most fluid was concentrated by counting the number of droplets each presented for each half meter of the tarp. Sneezes vary a lot between people, and drops squirted from a dropper vary too. So I couldn't squirt each type of snot just once. I needed to squirt each kind many times. Running the experiment multiple times would help me avoid 2 types of error. I would make a type 1 error if I concluded the 2 kinds of mucus were different when they really weren't. This is a false positive. I'd make a type 2 error if I concluded the 2 kinds of mucus were the same when in fact they were different. This is a false negative. I can never totally eliminate the possibility of these errors, but running the experiment more than once lessens the likelihood that I make them. But how many runs of my experiment would I need? To find out, I would have to do some figuring. Scientists generally agree that 5% chance of a false positive is acceptable. This is called an alpha. False negatives aren't quite so bad, and an acceptable risk is 20%. It's called beta. A beta of 20% would give me a power of 80%, or an 80% probability of finding a difference between my 2 kinds of snot. With a power of 80%, I could use the chart from 1992 paper by Jacob Cohen of New York University. Free copy is here. This chart tells me that to compare 2 groups, finding the mean difference, with an alpha of 0.05, I would need to squirt each type of snot 26 times to detect if there's a large difference between them. So I did. I squirted, measured, and carefully wiped up each type of mucus 26 times. I made sure to write down all of my measurements as I went along. Click on this picture, and here is your link to go to your video.